So, hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 196, and in this video we talk about the keyword new. And when we talk about the keyword new, we have to talk about the keyword delayed as well, because these two keywords come in combination. Alright, let's get started. Here we start with the keyword new, and here we see we have the use case new expression. Let's click on it and let's read what this new expression is. Only the first sentence here, and it says here creates and initializes objects with dynamic storage duration, that is objects whose lifetime is not necessarily limited by the scope in which they were created. So what is the meaning of that sentence here? The meaning is very simple. It is just creating a variable, and this created variable is different from a normal variable that it has a dynamic storage duration. Let's make here an example so that we get that we understand this. And here you can see I have created here a block scope, and in this block scope I will create a normal variable, for example int, and I call this my telephone number, and I initialize it with a number here. Let's make a short one. And you can see this is creating and initializing an object. The difference is this one has not a dynamic storage duration. This one, we already know, has an automatic storage duration. What means automatic storage duration? Automatic storage duration means when you create this variable in this scope and you leave this scope, the compiler will really destroy this variable, or let's call it release this storage of this variable, which means you can reuse it for other purposes. And now let's go back to our new expression. So here we are creating also an object, and we can also initialize it like this little one here. But this new expression, the difference is the storage is now dynamic. Let's click here and read what dynamic means. You can see we have here again the storage class specifier. You can read here again this page, and when we go down to storage duration, you can see we have here this automatic storage duration. That is what we have here. And then we have the static storage duration. That is this word with the static. We have talked about this word static. It has different meanings in different places, so careful about this one. But we have now here this dynamic storage duration, and when you read here this sentence, it says here the storage for the object is allocated and deallocated upon request by using dynamic memory allocation functions. So this dynamic storage duration, there is special functions, and the special functions here are dynamic memory management. So this is a special place with libraries, which makes it much easier to handle this. But we skip this dynamic memory management libraries for now, because we have to learn first the basics, and the basics are when we go back here to our new expression, how to use the syntax and how to go on. But anyway, it's very important to understand this here, and this here is described in the next part here. The next part says dynamic storage duration, objects whose lifetime is not necessarily limited by the scope in which they were created. We have to understand this part, and this part is a little bit difficult to understand as a starter. That's why I will make here an example. But before I make an example, let's talk about the syntax. And we can see we have here 4 different kinds of syntax. We will use the second one. And you can read here again, the first one and the second one are almost identical. The difference is this one has here round brackets, this second one not. And then you can see here are some additional infos which we have to take in account. All right. And yeah, let's use this syntax here for a demonstration. Let's copy this one. Of course, we will use the syntax to see if this works. So what I want to do with the syntax is exactly what they described here on top. We create and initialize an object with dynamic storage duration, this here. we are doing that. But before we do this, we have to go down to the explanation, because here is something very important, and that is the return value. This is this part here, which says the new expression. This is that what we are talking about, and that what I want to create now, variable. The new expression returns a PR value pointer, and this one is very important. What is a PR value pointer? P stands for pointer, R value stands for something that is not saved. Think about it all time temporarily, and when we compare it to this one here, this one is a variable, but this variable is a L value because we can call it again, right? I can call this one again my number. I can assign it a new value, and the reason for that is because this one is safe fixed in a place, and the R value is, for example, what is our R value here? We have here our R value as well. This one, this little literal is an R value. Why is this an R value? Because this 43, I don't know where it is safe, and I can't change its value. Something similar like that. So, and here we learn now this PR value pointer. So what is then a PR value pointer? Like I said, P stands here for pointer, R value, and we make a pointer which is an R value. So this is our return type. In short, this expression here, this syntax, what we create, is returning a pointer R value, which we have to save in a variable or we can't use it. All right. So first of all, we have to create a safe place. So or let's start with this one, and then let's create the pointer, because then we see why we have to create a pointer. All right. So let's start with this PR value. Let's write it here as well. PR value pointer. Pointer is return type. Okay. Return type. So okay, let's do this, and let's follow this syntax here. All right, the first thing we have here, this resolution operator, the scope resolution operator. Important is if the scope resolution operator has on the left side nothing, and you can see here on the left side is nothing. If this is the case, they mean all time the global space here, also which is defined global on this file. And if there is on the left side something, then they mean anything special. For example, on the left side could be a namespace, a class, which we already know. But important is this one. Probably you don't see this one often, but now you should remember this. This means the global namespace. We skip this part for this creation. We go here directly to the word new, and then we go to the new type. This is the type which you want create. In my case, I want create int. But what means this type, by the way? It's very important that you understand also the meaning of this type here. The meaning of this type is how much storage you want. That means the type. Why? What has type with storage to do? The type is the in general determines how much storage the compiler will reserve for you. And how can we check this? There is an operator. If you should know this, let me show you the operator how you can check this. It's different on different systems, but you can all time use the size of operator. Oops, I built accidentally, but you can use all time after this one build it. All right, let's close this. So you can use the size of operator. I demonstrate you this fast. So to check here, for example, this int, how much size you want, how much storage size you want, you write here size of, and then for example int, and then you can see this integer type on my machine when I start has how much bytes, and these are bytes, 4 bytes. And 4 bytes in the 60 bits, right? No, 32 bits, sorry, because 1 bit 1 byte has 8-bit. Okay, this one we know, and we can find out how much storage we want require. Let's keep this one here as well, just as an info. So we go on. So we created our type. So we say, okay, I want 32 bits here, and then I want this initializer, which is again optional, but we can. Important is here, this initializer can't use the copy initializer, which is our equal sign. I can't use this one here. At this point, normally you would initialize this perhaps most time with copy, but we know there are 2 other initializer as well. This is the round brackets initializer, but this is also not safe because here you are allowed to do something like that. This we already know as well. It is called narrow conversion. So this one converts to an int and skip this decimal points. But if you want to avoid this, like all time, use the curly brace initializer, the list initializer, which is new and much more safe. And the reason why it's much more safe, you can see here, it is saying this one is not allowed. You need a narrow conversion, and that's a good thing because now you can initialize this intentionally, which means we already talked about this as well with, for example, static cast, or you can just use the narrow initializer because now you know at this point, yes, I can skip or not skip. So with that said, you can see this is important that you know we have only this 2 initializer here available, but now I created a variable to here. I created a variable, and here actually I created here not a variable, or let's say so. Here the difference here and here is here at this point I created a variable which I have named, and this named variable has the value 43 in it, but the compiler has assigned the storage to this variable here. So, and here not. And let me paint this a little bit so that we understand this a little bit more. And by the way, there is one more thing which is very important to understand, which I forgot to mention, and that is this one here. The normal variable is created on the stack, and this one, which we are using with the keyword new, is created on the heap. And I hope you read already about the stack and the heap, because I will not go into theory, but I mentioned just short what the main difference is. This variable on the stack is the much faster than the heap, and the reason for that is because they have a different order system. They have a first in first out system, and this one has their own system, and that's why this one is much faster. But because this special order system, they make the stack very limited, around 1 megabyte. So with other words, on the stack we have around 1 megabyte, but can be different from system to system. Other systems can have 8 megabytes or user defined megabytes, but important is it's very limited compared to the heap. The heap can have over 100 gigabytes. And to read this more in the theory, but let's go to the paint and see how this both parts are created. So for this purpose, I make a short drawing. This is my first let's say this is my this one is my heap in my stack. Let's make it this way. That's okay. Let's put it here perhaps. And so, all right, and let's write here perhaps this one is our heap. This one here is our stack. So our stack, and the heap and stack is just memory, right? And okay, and then we create now this variable, and now we create also this new function, and see what happens here a little bit. It's not accurate. Careful about my diagrams. They are all time not accurate, but they visualize the principles a little bit. So here we start with this one here. We create now this variable, my telephone number. Let's make this name here short so I can write it faster. Let's call this just number 1. Just let's call this number 1. All right, so now my number 1 here is created on the stack, like I said before. But let's write some more information. The stack as what? The stack is fast. Okay, stack is fast. As the principle of yes. I think you know this principle, one of this LIFO or FIFO, I don't know which one, but one of them, it has it. Check it out which one it was, but just is fast. And then we need to know limited, because let's say it's around, I don't know, around, how much is the stack? Depends on the machine. Let's say 1 megabyte till 8 megabyte, something like that. Can be even more. This one is just some examples. And then we are creating now this variable, and normal variable, automatic variables are created on the stack. So let's write here also automatic variables. Automatic variables, right, are created here. Oh, let's go here. What? What's that? Don't know what this is. Yeah. All right, so we have automatic variables are created here, and now we make this example here, and now I draw, that looks bad, but it's okay. First of all, how this variable here is created here on the stack, you can see we have a int, we have a variable name number, and we have a value 43. So first of all, this int, like I said, the compiler will use this size of operator or something like that to determine how much byte this type has. So this type on my machine, before we saw it has here with this command here. When I start this one, okay, my machine has 4 bytes. All right, 4 bytes. So the compiler says, okay, for the first variable here, I give you 4 bytes. Let's make here and here a place. Let's write here 4 bytes in. Okay, this is this 4 bytes, and I write here 4 bytes. 4 bytes, just as an info. And the next thing, this is my integer area, storage area, and this integer has the value 43. Let's throw in the 43 as well, and this integer value we throw in this storage place anywhere. All right, this is now saved. That was this one here, and after this one here, it's finished, because and it's not finished. We have one more thing. We have here this variable number. Okay, and this variable number is associated with this storage. And let's write this number here outside, and number. And this number is associated with the storage. How this associated is, it's more technical. We can skip this. We know it is associated. Let's make still a pointer to it. It's not really a pointer here, but it's associated with this number here. All right, that's okay. So now we are doing the same thing with our new expression. You can see the same thing here. First of all, the new expression is on the heap. Heap is slow, but heap is not limited. And not limited means we can here from 1 gigabyte to over, let's make here over 100 gigabyte. Also, let's write here over 100 gigabyte possible. All right, I write here gigabyte. So over 100 gigabyte possible. That's okay. And this here is not automatic variable. We have now dynamic, dynamic variables. Let's call them, let's call it, actually I called this wrong. This is automatic storage here. I should change this, sorry. Dynamic storage. Okay, here we have dynamic storage. And this here is automatic storage. Sorry for that. And the reason why I have to change this to storage is the behavior of the compiler. It's very important because we saw before, dynamic storage means the compiler will keep the information, and automatic storage, the compiler will release the storage. And that's very important. Let's write here automatic storage. All right. Okay. So here, automatic storage, the compiler will release this later for us. Here in the first example, when we go out of scope, this automatic storage means the compiler will release this storage. We can reuse it. Or dynamic storage means when we go out of scope, the compiler will release it not. When we go out of scope, we make here an example. So here again, we have here again int, and this int will again use the size of operator, and it will use a little bit more. There is another function. When I hover my mouse over this new expression, you can see there is another function. It is called void asterisk. We can ignore this C deckel. This is just Microsoft or something like that specifier, but important is it says here void asterisk operator new, and then here is the size t. The size t here will determine how big the size is, and this size t here you will see it's calculated with size of, and there is one more function aligners or something like so called. But important is that you know that this one here will calculate this storage with this storage function here, and this storage function which you see here on the tooltip, I have to show you this one as well. When I go back and click here, the second use case, allocation function, and that is this allocation function here, which we see here. Let me click on it, and you can see it. The allocation function is called operator new, and here this function, the first one, look this one careful, this one is exactly this expression of the new. You can see the only difference is here is one more specifier, but ignore this. Here it says void asterisk also void pointer. This is our void pointer, then operator new size t size, and here it is using this one. But here one very important note, and the note is this operator new is called by the new expression here at this place. It is called by the new expression, which means as a default call. But this operator new here, when you as a programmer call this one, it has another meaning. What is the other meaning of this operator new when you as a programmer are calling this one? If you are calling this operator new here active, it means you are trying to overload this already existing operator here, function, allocation function. This one is an allocation function that already exists, but you can call it and change the function meaning. And we talked about operator, right? This here, we have here an operator operator keyword, and operator means all time you are trying to overload something. Not all time, but most time you have to go to the operator overloading section. We talked about this operator which are allowed to be overloaded here on the bottom, and I made this example with plus. But important is here, look here, this section here is operator new, also defined as something you can overload, which means in short, in the function body you can define your own behavior. And here is this delayed keyword as well, which we have to learn in combination with new. So that's very important. So when you see this one here, this one here. This is the allocation function which the new expression is calling behind the scene, the default one. But if you are using this one active, it means you are overloading this one. And the reason why I point this so out is many people are confused about the word operator new and the expression new. They are mixing this one up. Try to understand this difference here, because some people will call this new expression also operator new. This is not an operator new, this is new expression like this one. And you can see the new expression, this one here, is calling behind the scene the operator as a default function to allocate storage. And now I show you this in my diagram. So this expression here, we said, okay, this one is created on the heap, we have all this kind, and now this new expression is calling this operator, and this operator is calling later size of again, and then it checks, okay, size of what? Size of this int here, which you have specified. This is the type which we want. In my case, int. Okay, the int has on my machine 4 bytes. So here in my case also 4 bytes. Let's write here also the same thing, 4 bytes. Again, 4 bytes. And then the value, this is the initializer. I used one. Okay, let's initialize this. Also with, let's make here another value, not the same. Let's make here this one. So I initialize this one with 433. So here I have this value here. And now interesting is what comes after this one here. What comes after this one here? And now we are go back to our PR value, which I started. This strange pointer R value. So we have to create here a pointer R value to this block here. And how we create this? It's very simple. It's actually just a pointer who points to this place, because this is the return value. And this, let's say this is a pointer, and let's make this symbolic with this asterisk. So we have here a pointer, and this pointer here is an R value, which means if you don't save this one here, then you don't know what is pointing to this place here. So that means we have to save this pointer here, because this pointer, what you see here, is the return value here, and we have to save it so to be able to use it. In this case, the number, the variable here, was assigned here. And technical terms, we don't need to know this. Now, if you want, of course, read this to understand this better. But in this case here, the return value is this pointer, which we have to save so we can use it. So with other words, this one here, you can't use it because it is just created and then it's gone. And the problem here is probably if this is created and not released, then you have wasted here anyhow storage, because I said when you create something with the keyword new, you have to use the delayed keyword as well to free this memory. And the reason why you have to use the delay to free this memory is because the compiler, and that is another very important note here, compiler is not releasing the memory in this heap. This is your job as a programmer. That is the dynamic storage duration. You are responsible to release this storage here. And automatic storage duration, here the compiler will release this storage duration. And this is the thing what you have to learn and understand. And that's why we have also learned the keyword delayed here in combination with new. But let's finish first this one here, and then we go to the delayed section, which is actually easy. So what we have to do now is, first of all, we are here. We created now this storage, we assign this value, we have this peer pointer, and now we go here and to make it useful, we have to assign it to a pointer. But this time, not a R value pointer, a L value pointer, which means a pointer which we can call. This pointer we can't call, but this pointer, let's create one. Int pointer, and this int pointer I call my pointer to heap, my pointer to heap. And at start we learned with pointer you should, when you are not assigning it directly to anything, start with a null pair to make it safe. And this is just a normal pointer creation. But what is the difference about this pointer and this pointer? Fast, it's very simple. This pointer is an L value. This L value means it is fixed saved and I can call it, right? So this pointer, my pointer heap here, I can call it. And now I have just assigned this value, which I created here. And the better way is, careful, when I use this one here and use this one here, it's better that we are assigning it directly when we create it here. So let's make here an assignment and directly here. And that is one way to create it. So let's see what I did here again. So in our diagram, what I have done here is I created, let's make here also a little bit shorter my heap. Let's call this pointer just pointer 1 to make it a little bit short, and this one also pointer 1. So because I need to write this here in this diagram, and yeah, so let's create here this int pointer. So let's write here int no, not with this color here. So here's my int pointer. Here's my int pointer. This int pointer is pointing, doing what? You can see this one here is now pointing exactly to the same place where this expression is pointing. The expression is a pointer, and pointing here, my pointer is assigned where this expression is pointing. So this pointer is now pointing here too. You can see I point here to this place as well. And because I can point to this place as well, I can use the storage now. So with other words, you have to understand, we have to create a pointer to be able to use this storage on the heap. And one side note, when we create a pointer, pointers are in general very, very danger when you are not careful, because we will see in the next video probably why, but in general they are very danger. And therefore when I go here, where was this with the storage duration? Yeah, it was here. When I go to the storage duration one more time, and so I show you that again. Where is that with the storage? I'm all time blind when I try to find. Here is the storage again, and here we read this dynamic storage duration, right? And we read that they are using these special libraries, right? And you can see the special libraries here to manage this dynamic memory. There are pointers as well, and in future we will use more this unique pointer or shared pointer instead of our normal pointers. And the difference here and here is that this unique pointer or shared pointer have a mechanism to make sure that this that the storage which is here allocated by us is also later released when we leave the scope. We have to understand this a little bit more in detail probably, but this are very important for the future. We will not use normal pointers, at least you should not use. Of course you can use this one here, what I showed you, but to be safe we will use something like unique pointer. The problem is we have not talked about this template, but this unique pointers will save us a lot of headache. And yeah, that's why I mentioned this one. So think about it. And there are much other classes here too, which is helping with this dynamic memory management. And you can see this dynamic memory management is in general, let's say, a little bit danger. And the reason for there is so many places what can go wrong. And therefore they make here a whole library to manage this a little bit better in better ways. They tried it and so, and we have to talk about some of these libraries to, yes, to use it better. But we are starters, we learn the basics. We are happy when we understand the basics. And I hope that you understand some basic, but we are not finished. We are not finished. There is one more thing which we have to understand. Oh, there are several more things which we have to understand, but here's some more important. So I created this pointer. I point now to the storage. I can now assign with this pointer. Now I have a L value pointer. I can assign with this pointer 1 here new values to this, which means, oops, not this. Of course not so. I should use the pointer as a difference operator. And then you can assign new values to it. So you can see with this pointer, I can assign with this difference operator, which is this asterisk in front, new values to it. But now the important part comes. What happens if I go out of the scope? So let's say here, in this case, like I said before, it is automatic storage duration. You go out of scope, the compiler is releasing this memory here. So you don't care what happens with the storage here. But in this case, the dynamic storage duration, this storage you create here at this point, you go out of scope. And what happens now? Let's think about this one, because this is already one of the problems. What happens when you go out of the scope without caring about the storage here? When you go out of scope at this point, the compiler, I mean, when I run this one here, let me run this one, and I have, you can see it shows nothing, but I created a memory leak. At this point, I created a memory leak. Let me show you what this is in this definition. When we go here to new expression, you can read here a little bit about allocation and all this information. But here on the bottom, there are some memory leaks. And memory leak means, you can see this is more or less this same example here. And it says if pointer goes out of scope here. In our case, my pointer goes out of scope. At this point, my pointer goes out of scope. What we learned is this pointer here, what I created at this point, when this one goes out of scope, the compiler will destroy this pointer because we're going out of scope, which means this pointer exists not anymore, right? That means the pointer where it pointed is no more accessible, which means in our diagram, when we go here out of scope, this pointer, what you see here, is destroyed when I go out of scope, which means this address, which was our responsibility to release before we go out of scope, is there and stays there forever as occupied. And occupied means you are now filling your heap with storage which you can't reuse again. And that's a big problem of many big problems. You can see this is only one. There are millions of other ones. And we have to deal with it. And to deal with it, we have to use, and now we go back to the second keyword. which is the delayed. We have to learn what delayed is. And here we have again this delayed expression, similar to new expression. And here we have also the delayed allocation function, similar to our allocate function to new. But when we go here to the delayed, there is only this little syntax. Let's copy this one here. And then you can read here a little bit what it means. And then you have to delete that what you want to use, right? So that's very important. And I won't talk about this delayed node in the next video, because you can see we have to talk here a little bit again about this explanation. And I won't talk also in the next video about, before I use delayed as well, about this memory, oops, not here, sorry, about this memory leaks. Where are they? I meant delayed expression, that's why. We go here about this memory leaks here a little bit more, which kind of sort there happen. And important is also, I think there was one more thing very important. Yes, this array, we will probably just to make some examples after we understand it, because there is also arrays, and arrays are even more complicated, but yeah, are more, let's say, confusing. I think we are going and do all this kind of stuff in the next video when we learn also delayed. But important is that you understand, without releasing this memory, and this memory releasing is your job now as a programmer. That was till now not your job. The compiler was doing it for you all time, and that's why this was very convenient to use not the keyword new, but when you use this keyword new, then you have to be careful and you have to release this memory storage all time. If not, you get here this so-called memory leaks, which means they fill up here memory, and it's not reusable again. Because what normal happens here is, on this side, if the compiler goes out of the scope, it says, okay, this number is out of scope. This memory where I saved now this number 43 in this 4 bytes, I release this. So the compiler is releasing it here. And later when you create, for example, another variable outside here, let's call it int other number 2, and let's assign it here this value here. What the compiler is doing here at this side, you see here it is released, and let's make it, for example, with this color. Yes, and with this color here, the compiler comes here again, checks, here's free memory. I can start here at this time, and now I go till here. And then it's doing the same thing what we did here on top with this number. Now it says, okay, this one is also int, so I have here 4 bytes. And here I assigned this value in, which is then 232. And the other one, this blue one, was before released. So this blue one was released, right? With other words, this one exists not anymore. And you can see it is reusing this place again. And this was all time the compiler doing. And now this is your job as a programmer to release this place so that it can be reused here again. If you understand this one, and later we understand also a little bit the mechanism, what we have to do to release it, and yeah, then you have understand this expression new. But we talk about this in the next video a little bit more in detail, how to release it and what problems there are, and of course a little bit also about arrays. This causes even more problems. But yeah, more in the next video. If you have any questions or any suggestions, like all time, write it in the comments. See you in the next video, and like all time, have fun and never give up. Bye.